So our next speaker appeared in a Cheetos commercial when he was 8 years old. Please welcome Matt.
All right, great. Well, I want to start with Lord of the Rings. People have seen it, right? I'm getting a little old, so like I run into people who haven't seen it. People have seen this movie? All right, has anybody not seen it? Okay, I think these are recorded talks. Jerry, is it okay if I tell him he can just leave and go see it? Like, it's really good. You should just go, and it's really great. So, but I'm going to ruin something for you. I apologize. Okay, so we're looking at two characters here. One of them's Frodo, the supposed hero of the story, and then one of them's Sam. And I don't think it's that controversial of an opinion, but even though Frodo's supposed to be the hero of the story, I actually think it might be Sam. Does anybody agree with me on that? Like, that's not crazy, right? Like, Sam is the guy. Okay, I see some thumbs up. All right, so Sam is like the sidekick, but like he's got some amazing kind of heroic moments in the movie. And there's something analogous going on right now with ChatGPT and embeddings. Okay, so everybody's talking about ChatGPT. ChatGPT is the hero of the AI story right now. But I want to convince you that actually embeddings are kind of like the secret, the low-key hero, the like really interesting thing that's kind of going on with OpenAI right now. So that's what this talk's about. Embeddings are cooler than ChatGPT. It's an introduction to embeddings and how to use OpenAI's embedding endpoint. Quick survey, who knows what embeddings are? Okay, this is a decent chunk of folks. All right, so I just wanted to kind of feel the room there. All right, let's do another quick survey. So this is about ChatGPT now. Okay, so if you think about ChatGPT on one end of the spectrum, you might be underwhelmed. Okay, you're like, yeah, it's not that cool. And then the other end of the spectrum, you might be freaking out. Okay, you're like, this is gonna take all our jobs and humanity's gonna get wiped out. I don't know. You could be on either end of the spectrum. I've been on both ends of the spectrum over the past few months. So I'm curious, like, who's kind of on the underwhelmed side? Can you just raise your hand if you're like, it's not that cool? Got a couple hands, okay, all right. Okay, cool. Who's on the like freaking out side of like things? They're like, okay, all right, cool. All right, good. We got a good mix of folks. So, all right, now that we've kind of pulled the room, I'm just gonna quickly walk through kind of the agenda for the talk. So first point, I'm gonna try and push the people who are freaking out a little more towards the center. All right, so ChatGPT, it's cool, okay, but it's not that cool. So that's the asterisk, right? It's like, it's definitely cool, but it's not that cool. We don't need to freak out. Second thing, embeddings are actually the cooler thing, I think, and then how do we actually use them? All right, so let's start with why ChatGPT isn't that cool. So again, thinking about the spectrum, like, some of you are on the freaking out side of things. Maybe like a lot of AI influencers are over there, right? They want us all to freak out a little bit, get those clicks. Maybe there's like, average Joe a little bit closer to the center. And then there's me, right? Is my clicker dead? Oh, there it is. So that's kind of where I am, just so you know, like cards on the table, okay? So I want to share a few things that kind of pushed me from the freaking out spot to more towards the center of this spectrum. First thing is a tweet from somebody who did, I think they were at Meta, they did AI research, and now they're a consultant, and they mentioned something really interesting. They called it prompt drift. Have people heard of this before? Okay, cool. So a couple folks. So they're doing some consulting. They're helping people build systems on top of ChatGPT. They're doing these kind of prompt engineering type things where they come up with these elaborate prompts, and they kind of deploy the system, and then the model changes, and then it just stops working, right? So there's like a little bit of a kind of a house of cards thing going on a little bit with some of these actual production ChatGPT-based systems. And I thought this was really interesting and something that's kind of under-discussed. And so when I found that, I was like, okay, like, it's not like these systems are just crushing it kind of consistently. There's some reliability issues that folks are worried about. So I thought that was interesting, pushed me a little more towards the center. Here's another tweet. This is from somebody who has been playing around with agents for a few months. Agents, if you don't know, this is like going a step beyond the kind of question and answer interaction that you typically have with ChatGPT and actually like doing things on behalf of the user. So you would give it a task like, I don't know, book me a reservation, at a restaurant, and it would like, click through some web pages to kind of do that. And so the important parts of this tweet are highlighted in red here. Basically, this person's been messing around with agents for about 3 months, And I love this line here. They said, they are looping computer programs that have a 5 to 15% failure rate every time you execute a new loop. So again, there's like kind of reliability issues here. Like you can look at kind of the splashy demos that OpenAI or other folks kind of put out, but the kind of word on the street or the kind of feedback on the ground as people try to build real systems with this is that there are some reliability issues. This is a really interesting example. You might recognize this. This is an example from a New York Times article. And the example is it's an instance in which GPT-4 is actually worse than GPT 3.5. Okay, so the dominant narrative about the iteration on these models is that we scale them up, we give them more data, and they get better kind of across the board. But it turns out that this isn't like always true. And so I'll just quickly walk through this example. So the prompt is, imagine an infinitely wide doorway. What is more likely to fit through it, a military tank or a car? So it's a little bit of a riddle here. And GPT 3.5 correctly, you can see this highlighted part here, says that the height and length of objects could be potentially a limiting factor in the doorway, whereas GPT-4 doesn't really pick up on this nuance. So I thought that was extremely interesting, and again, it really challenges the narrative that you just make these models bigger and they're going to be better. So I think, oh yeah, one more thing. Do people know about this? Like Sam Altman made this comment at MIT maybe a month or 6 weeks ago. This the age of large, giant models is kind of already over. Have people? Just raise your hand if you're familiar with this comment. Okay, so a couple of people. Okay, so again, a big kind of piece of the narrative around AI is this idea that you just make the model bigger, you give it more data, and it's going to be better. And here we have Sam Altman, the guy running OpenAI, saying, actually, it's not that simple. And actually what he says in this talk is he says, oh, I think we'll actually make models better in other ways besides making them bigger. And it turns out if you looked at the GPT-4 leak, they are actually just doing a mixture of experts type thing for GPT-4 if you take the leak seriously. And so that again challenges this idea that the path to AGI is really straightforward. We need more data and a bigger model and more venture capital and it's done. So the path is actually not clear, I think, to really get to a version of GPT that's going to take over our jobs. Okay, so GPT is cool. It's not that cool. We don't need to freak out. Why are embeddings cooler? So let's just talk about what they are really quickly. Okay, really concretely, it's you give a large language model some text, and then it spits out a list of numbers, okay, or an array of numbers. In the case of OpenAI's embeddings, it's a 1,536 length vector, okay, of numbers. And what these numbers allow you to do is essentially compare strings according to their meaning. Okay, so if you look at this is kind of small, and I apologize for this, but these are words that have been embedded in a model. They're obviously projected down from a high dimensional space into a two-dimensional space so that we can actually look at them. And you can see that words that have similar meanings cluster together. So things like eagle and deer here, those things are close together because they're animals. Ants and bees are close together, they're insects, cranberries and grape. And so essentially you have this way of kind of measuring the relatedness of text strings. It's not just words, it could be phrases, sentences, entire documents. Now, the reason I think this is interesting, or actually let's delve a little deeper though into where these embeddings kind of come from. So if you think about the pieces that make up ChatGPT, there's two pieces, okay, and you might know this already, but there's kind of just a straight large language model portion. Oh, actually, let me talk about this. My slides might be out of order. I'll talk about this first. So I'm not going to do that. I'm sorry. So let me. I remember the order I want to do this. Okay. So sorry about that. So there's two pieces. Let's talk about the second piece first. This stands for reinforcement learning with human feedback. Okay. This is something that that's kind of done after the large language model is trained, and it's something that allows them to tweak that model so that it's more aligned with, the prompt that we're actually asking. And this something, as the acronym suggests, it's something that requires human feedback. Like there are people that are actually, saying like this is a good response or not a good response, in order to kind of fine tune these models a little bit and make them more aligned. And this is actually a point of failure if you think about it in like ChatGPT like systems, because there's basically if the prompt that somebody enters is too different from the training data or the data that we've received human feedback on, then the model's not really going to be able to handle it well. And this is actually, I think, probably what happened with GPT, like this regression in GPT-4, right? Is that it just wasn't in the training data set, and so it wasn't able to handle this sort of query well. And so that's a point of failure in these systems. Let's talk about the other part of it, and this will actually get into where embeddings come from, and we'll see how embeddings don't suffer from the same sort of point of failure that you see with a ChatGPT that's based on this reinforcement learning human feedback piece. So the other part of these systems is just the actual large language model itself, and the task that this model has is to basically, given a sequence of text, to predict the next token, right, in that sequence, or maybe it's predicting a token or a word within in the middle of a text sequence. I'm sure we know that already. So that's what these models are doing, and it's a neural network. It's a deep neural network. And so the output of this network, if you look at this last layer here, the output of the network is its prediction of the next token, right? But the layer before the output layer, okay, so let me see if I can use this like laser pointer here. Boom. This guy right here. So this is the output layer. Okay, this is actually doing the prediction of the next token. This layer right here, this is where embeddings come from. Okay, this is like we pluck this layer out right here, and this is basically the embeddings that you're working with like OpenAI or any other kind of embedding system. And so essentially what you have with embeddings is it's the LLM's representation of language that is useful for predicting the next token in a sequence. Okay, so when you're working with embeddings, you get to pluck out that model's understanding or representation of language, and you get to skip the finicky behavior of ChatGPT. That's what I think is really interesting. Okay, and you can do some really powerful things with this model's representation of language and not suffer the same sort of reliability issues. So here's one thing that you could do. So Jared made this joke about, is anybody even using Twitter anymore? But like one project you could imagine is like, oh, I might want to do sentiment analysis on people tweeting or threading about Twitter or Threads and like understand what the overall sentiment is about these two social networks. And so with embeddings, what you could do is you could actually embed, you could just embed the word like this is, or the phrase this is cool or something like that, right? And you're going to get some vector that represents that. And then you can compare that embedding to all of the tweets or thread posts, that the embeddings of those tweets or embeddings of those thread posts, and see like, oh, is it closer to like this is cool or this is lame? When you kind of compare those embeddings, you can do like a distance measurement, like a cosine similarity or something like that. And so what you essentially have here is like a zero-shot classification system where you don't need to necessarily train any new data for this specific task. You can just use the embeddings to actually do sentiment analysis, which I think is really cool. Another example of this that's kind of similar is product recommendations. So imagine you take a bunch of descriptions of content on Netflix. You embed those descriptions, and then those descriptions might be for films or shows that a particular user is watching. And so if they have kind of consistent preferences, the embeddings of those descriptions are going to cluster in the kind of high dimensional embedding space. And then you can recommend, if you embed kind of the entire library of Netflix, you can recommend similar shows or content that is close to that cluster in the high dimensional embedding space. And again, you can just do this like kind of trivially, just piggybacking off of the large language model's representation of language. So I think that's another really cool application. And then another one, I have to bring this up because we're at an R conference, but let's say you're working on an R project and you want to find a particular usage of a function, okay? I'm sure you've run into this before where you search for the function and you can't quite remember the name of the function that's being used, you miss one word or something like that. So maybe you're looking for bind calls, the tidyr stuff, and you accidentally type in bind columns or attach columns or something like that when you're searching. So with a standard search system, you're kind of out of luck, right? You're just gonna turn up empty. But again, with embeddings, let's say you embed all of the function declarations within a code base. And then you also embed the user's query for the function that they're searching for. Then you can actually start to search for things based on the meaning of the words involved. And so even if you don't exactly get the function name correct, you're still going to be able to surface similar function names that are close in the embedding space or have a similar meaning. And that, I think, is really cool. So let's actually talk about, we only have 4 minutes. Let's talk about how to use these things. So using embeddings with OpenAI, it's not that hard. So you can install OpenAI package, and then there's a create embedding function that you can use. There's a specific embedding model that you can specify. ADA02 is the one that's recommended. And then you can just give it phrases or words or documents, and it will embed these things. So it's not too difficult to create them. Again, you're going to get this, 15. It's like an HTTP response, and inside of that is this 1536 length vector. And then from there, it's actually not that hard to project these kind of high dimensional vectors into a two-dimensional space and plot them so you can kind of see the relationship between the text embeddings that you've asked OpenAI to embed for you. So this is just a few lines for how to do this. I'm not going to walk through this line by line because we're a little short on time, but basically, if you have code like this, you can get a nice ggplot. And you can see here, the terms that I embedded were dog and cat, banana and apple, and democracy. The dog and cat kind of cluster together, banana and apple cluster together, democracy is far away, right? It's these are different concepts. So that's kind of a neat thing. And then this, I actually do want to spend a little bit of time on. So if you wanted to implement this kind of semantic search thing, this example of semantic code search, it's, again, surprisingly easy to do. You can do it in a few lines. So first you're creating the embedding. Okay, we've already seen this, a line like this before. You have to grab the actual embedding vector itself from the HTTP response. That's all that's happening here. And then suppose you have a string here. This is the user input. So we're basically just embedding that here in these first few lines. And then let's say you have a tibble of embeddings of terms and the actual embedding vectors associated with that in a list column in a tibble. Then what you can do is you can mutate in the cosine similarity of these things. And so you compute that as a column, and then you can just arrange by this. And so here what you have is you can rank all the terms that you've embedded by their similarity to a particular input that's been passed into the function. And so it's really neat how just in a few lines of code, you could actually start to implement semantic code search or even thinking about things like product recommendation. It's a kind of semantic search, right? So kind of riffing on this, you can get pretty far. Okay, so we've talked about semantic search over functions and code. Obviously, another application of this is semantic search over documents. And so again, maybe you don't have to use the actual terms that appear in the document. It's just terms that have similar meaning and surface the correct documents based on that. But I want to quickly share, I have 1 minute left, how I'm using embeddings to do semantic search over application states. What does that even mean? So the application for this is basically, let's say you don't know how to do something in a piece of software. Let's say the software is Amplitude. Okay, so let's say you're using Amplitude, you don't know how to do something. The idea here is you can type what you want to do. So in this case, it's create a graph that shows the count of sessions over time, but it could also be, how do I add a user in Amplitude? You hit enter, and then you're going to get these in-app step-by-step directions on how to accomplish that task within the application. And we're using embeddings to do this. It turns out that if you embed the application copy associated with a particular page or application state, that application copy or text is a pretty good indication of what's possible on that page. And so you can kind of match up a user's query of what they want to do with the right page that they need to be on to do that, and guide the user into the right place. So that's something that, that we're kind of using embeddings for right now. And I have 7 seconds left, so it looks like I'm going to finish right on time.